All right, so this is day 3, which is area of regular polygons. It's the first day of it. So our goal for today is I can find the area of a regular polygon. I would rate myself pretty low if I was a student right now. This is not a formula that you regularly encounter, but once you know how to use it, it's pretty simple. Okay, so first off, a polygon is any closed shape with 3 or more sides. A regular polygon means that all the sides are equal and all the angles are equal. So if you look at right here, we also have 2 different types of polygons, convex and concave. The figures on the left, they're both hexagons, okay? Because this right here, let me highlight what I'm looking at. This right here has 6 sides, but it's convex. It's not what you probably think of when you think of a hexagon. This right here is a regular hexagon. If you look at it, if I'm telling you it's regular, that means all of these sides are the same, and then all of these angles are equal. Okay? All right, so next, let's get a little bit of vocabulary out of here, a little farther here. The center of a regular polygon is equidistant from all the vertices. So the center is this point right here. That's pretty obvious, right? Now, the distance from the center to any vertex, let me change colors here. The distance from any center to the vertex, center to a vertex, right? That distance right there is called the radius. Just like if it wasn't a circle. So if I tried connecting all of these points right here, oh goodness, I'm trying, right? You would see that's a circle, and you could see that that is the radius, right? Now, if you look at this other piece right here, the distance from the center to a side, which is right here, okay, that is not a radius. That is called the apothem. Some people pronounce it apothem. I personally pronounce it apothem. So that's the distance from the center to the center of a side. So this is an apothem. Apothem right here. Okay. Next, let's talk about a central angle. A central angle of a regular polygon has its vertex at the center and its sides pass through consecutive vertices. Each central angle has a measure of regular n-gon is 360 divided by n. So if I was looking at this hexagon right here, I'm going to erase where I wrote apothem. I'm going to erase my apothem there. I just called it apothem even though I call it apothem. If I drew in another radius right here, this angle right here, okay, that is a central angle. And to get that angle, it's 360 divided by n. Now, here's the thing is that we don't want that angle. We want this angle right here, which is half of that. So to get that measure, we're going to do 360 divided by n, which is the number of sides. And then you're going to take that and divide that by 2. Okay, that will give you this angle right here. Okay. Okay. All right, so total area of a regular polygon, here is your formula. So the formula for the area of a regular polygon is area equals 1/2 apothem times perimeter. Okay, so once again, that P stands for perimeter. And to remind you what the perimeter is the number of the sides, times the length of each side. And I shouldn't put each, just put length of side, because the sides are all the same, right? So please realize you might be saying, like, I thought you add up all the sides, but if all of these are 5, 5, 5, 5, 5, 5, 5, I can just take the number of sides, which is 6, and multiply it by 5. That's 30. That's what the perimeter is of a regular polygon. Okay, so that's our formula. an important formula here. Area equals 1/2 apothem times perimeter. All right, so before we move on, sometimes there will be a picture drawn of the polygon. Sometimes there won't be. So we have to make sure we know how many sides each one has. Okay, so let's review the name of a polygon by its number of sides. So if a polygon has 3 sides, that is a triangle. We know that. 4 sides, people accidentally always say square, and I go, too specific. And then they'll say rectangle. I go, way too specific. And then they'll say parallelogram, too specific. What word means 4? Quad. So a quadrilateral is any 4-sided figure. 5 is pentagon. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. 10 is decagon. 11 actually has a name, but we never use it, so we call it an 11gon. 12 has a name, it's dodecagon. Anything after that, we use the number -gon. So a 45gon is a 45-gon. Okay, so let's get into an example here. It says, find the area of a regular hexagon with side length 10 feet. Round to the nearest tenth. All right, so the first thing we're going to do is we're going to write down our formula. Since it's a regular hexagon, it's a regular polygon, we're going to write down area equals 1/2 apothem times perimeter. What then I like to do is I like to say, okay, I need 1/2 times, I need the apothem. And I say, was I given the apothem? No, it says side length 10 feet, so I'm going to leave a space for it. And if I need to make that space bigger, I can. Then I say, was I given the perimeter? And technically, I was not given the perimeter. I was given the side length, but I can quickly figure out the perimeter, so that's what I'm going to do first. I'm going to say, okay, the perimeter, I can figure that out pretty quickly. I'll just do it right above here. The side lengths are 10, and there's 6 sides because it's a hexagon. So the perimeter is 60. So I can put a 60 in here. It's actually 60 feet, but 60 is fine for now. Okay, so what I need is the apothem. So what we're going to do is we're going to start off by drawing an apothem in the hexagon. You're going to draw the center. Okay? To draw the apothem, you are going to go straight down perpendicularly to the side. It's going to form a right angle, and it's also going to cut this into 2 congruent pieces. This right here is the apothem. This is what we're looking for. Okay, so what you're then going to do is you're going to make this into a right triangle, and you're going to ask yourself, what do you know? Because you have to know at least one thing. You either have to know this, which is the radius, or you have to know this, which is half of a side. Since I know the whole side length is 10 feet, right? 10, 10, 10, 10. I don't need to do that, but since I know they're all the same, okay, I know that these 2 pieces are the same, and they're cut into 2 congruent pieces. So this is 5 and 5. All right, the next thing you're going to do is you're going to find this angle right here. Okay, and how are you going to find that angle? You're going to do 360 degrees divided by the number of sides, which is 6, divided by 2. So 360 divided by 6 is 60 degrees. 60 degrees divided by 2 is 30 degrees. So this angle right here is 30 degrees. All right, I'm going to erase this question mark because I don't have it, nor do I need it. I need to solve for A, the apothem. Now, if you wanted to, you could draw this triangle off to the side. If this was a really tiny figure, you could draw the triangle off to the side and say this is 5, this is A, this is 30 degrees, and say, how can I find that? And I'm going to use SOHCAHTOA, right? So I'm going to use a color I haven't used yet. Use purple. Here's my angle. I want to know how my 2 sides are related. This is opposite. This is adjacent. I could have also done it right from here. Here's my angle. This is opposite. This is adjacent. Okay, so if your figure is big enough where you can just write in it, great. If you want to draw the triangle separate, great. All right, which trig function uses O and A? Let's write down SOHCAHTOA so that we can remind ourselves. SOHCAHTOA. I'm also going to copy this so that I can use it later if I want, if I need it, I should say. All right, so I need O and A. O and A. That would be tangent. So I'm going to use tangent to solve for A. So I'm going to do tangent of my angle, which is 30 degrees, is equal to, and then remember, it's O over A. So make sure you're doing that. O is 5, A is A. All right, now I need to solve for A. So remember, if I'm solving for a missing side, I'm going to cross multiply. I'll put this over 1. I get A times, I don't like that circle there, A times the tangent of 30. So we're multiplying these two. Is equal to 1 times 5, which is 5. I still need to get A by itself, so now I need to divide by tangent of 30 degrees. Divide by tangent of 30 degrees. So I have A is equal to 5 over tangent of 30. Now you might be saying, but your calculator. Not yet. We're only going to round our final answer, so this is not my final answer. This is not the area. Okay, this is the apothem. So what I'm going to do now, this looks like 300, so I'm going to erase that and make it smaller, is I'm going to take this and I'm going to plug this in for my apothem right here. Okay, so that is 5 over tangent of 30 degrees. Okay, now I can delete that because it was in the way. All right, now I'm ready to pick up my calculator because I'm about to get the area. I have everything I need. Okay, so I'm going to go ahead and use this Calculate 84 app since it's readily available to me here. Now remember, the Calculate 84 app automatically resets to radian mode after using it. So you're going to have to hit mode, switch this to degree mode because we're using 30 degrees. Then you can quit out of there, and now you can type this. So I'm going to do 1/2. I need to put 1/2 in parentheses if I'm going to type it. I should write it properly. I can use 0.5 if I don't want to do that. Parentheses. 5 divided by tangent of 30. Close the parentheses, close the parentheses. Put them like shaded for you to know you to do that, and then times 60. Enter. And I get 259.8. And I need my unit. Now you might be saying, why did you round to the nearest tenth? Because it said so. So 0.8, that's why I used it. And then my unit was feet. So since this is his area, and this is a foot, and this is a foot, feet times feet is feet squared. And there's my answer. All right, here's the next one. I'm going to go ahead and get rid of this app, and I'll just pull it up as I need it here. All right, so the rest of them are all similar, but sometimes a little different because I can either give you the apothem or the perimeter. So let's see what this one I have. Find the area of the regular octagon. So I'm going to write down my formula for the area of a regular polygon. 1/2 apothem times perimeter. Area equals 1/2. Did I give you the apothem? With an apothem of 12. So I sure did. You can write that in. But I did not give you the perimeter. All right, so I'm going to leave a space for it. I like to leave the space big because usually it's something like funky looking. All right, now I need to find the perimeter. So I'm going to draw in the same thing I drew in on the last one. I'm going to draw in the apothem. I'm going to draw in the radius. So there's the center. I'm going to draw in the apothem. I'm not putting A there this time because I know the apothem is 12. That's a known. But I do know that that's a right angle, and these two pieces are the same. I'm going to draw on the radius, which I don't know. And then I'm going to find this angle right here. Okay, I'll put an X there for a second, but it's not X. It's not an unknown. How do I get it? I'm going to do 360 divided by the number of sides, which this is an octagon, so that's 8, and then divide that answer by 2. So 360 divided by 8 is 45 degrees. 45 divided by 2 is 22.5 degrees. So this angle inside here is 22.5. So you see how it's smushed? That's why I like to sometimes draw my triangle off to the side, because then I can make sure that I get the 22.5 in there not smushed. And then this was 12. Okay, so what am I looking for? Am I looking for the radius? Is that's going to help me find the perimeter? No, right? But if I find this piece right here, will that help me find the perimeter? Yes. If I figure out what that piece is, then I can double it to get this piece, and then I can multiply it by 8 to get my perimeter. All right, so let's find that piece there. We're going to call it X. All right, so here's my angle. This is opposite. This is adjacent. So if I go back to SOHCAHTOA, opposite and adjacent is tangent once again. Okay, so I'm going to use tangent. So I'll do tangent of the angle 22.5 degrees is equal to opposite over adjacent, x over 12. I'm going to cross multiply to solve for x. Put this over 1. 1 times x is x equals 12 times tangent of 22.5. All right, let's talk about the mistake that people will sometimes make. They'll sometimes take that and plug this in here. That's not the perimeter. X is not the perimeter, okay? So if I want to get the side length, how am I going to get the side length? This right here. I'm going to double this. So I'm going to do times 2. So if I multiply that by 2, I get 24 tangent of 22.5. So now I have the side length, but now I want the perimeter. If I want to get the perimeter, what do I do? How many sides are there? There's 8 sides. So now what I'm going to do is I'm going to take this 24 and multiply it by 8. What I could do is I could just do this 8 times and then 24 tangent of 22.5 and just leave it like that and then plug that in here. Or I think it's a little easier to do 8 times 24 and say what that is. All right, so I'll just do that on my calculator off to the side. 8 times 24 is 3024. So this is the perimeter is 3024 tangent of 22.5. That's not right. 8 times 24. 8 times 24 is not 3024. 192. Very wrong. Okay. 192 tangent of 22.5. I looked and I was like, what? That's so wrong. Okay, so that's the perimeter. I'm going to take that and plug that in right here. Okay, so 192 tangent of 22.5. Now I can get my calculator out. I have one in front of me, but just to make sure we know how to type it here. I'll pull this off to the side. All right, you can either do the 1/2 in parentheses again, or you can do 0.5 for half times 12 times 192 tangent of 22.5. Close the parentheses, hit enter. Remember, you're rounding your answer to the nearest tenth, so I'm going to put area equals 477.2 centimeters squared. Okay. All right, let's try one more. Find the area of the regular hexagon with a perimeter of 48 feet, round to the nearest tenth. So I start the same way. Area equals 1/2 apothem times perimeter. And then I ask myself, what do I have? Do I have the apothem? Nope. So I'm going to leave a big space for it. And I say, do I have the perimeter? And yeah, they gave me the perimeter is 48. They didn't even give me side length where I have to figure out myself. All right, but now I have to find the apothem. So let's draw that in. So here's the center. Here's my apothem. I don't like how it wasn't straight. Here's my center. That doesn't look like the center. Here's my center. Here's my apothem. All right. Right angle. This is my apothem, which I don't know and I'm trying to find. I'm going to draw on my radius. And then I have these two pieces that are the same. Okay, so do I know my radius? Nope. Do I know this piece? The answer is yes, I have to, because I can't have two unknowns. I can't say I have to, if I don't know my radius, I have to know something on one of the sides. So let's figure it out. We know the perimeter is 48. So this plus this plus this plus this plus this plus this is 48. So if I do 48 divided by the number of sides, which there are 6 of them, I know each side is 8 feet. So this is 8 feet. This is 8 feet. And I could keep going, but I'm not going to label this whole thing 8 feet. Instead, I can say that this little piece right here is 4 feet. All right, now I'm going to find this angle right here. All right, to find that angle, I'm going to do 360 divided by the number of sides, which is 6, divided by 2. 360 divided by 6 is 60. 60 divided by 2 is 30 degrees. So that little angle right there is 30 degrees. That's not too smushed, so I'm not going to redraw it. Instead, I'm just going to find that A value. So here's my angle. This is adjacent. This is opposite. Opposite and adjacent, just like before, use tangent. So I have tangent of 30 degrees is equal to opposite, which is 4, over adjacent, which is A. I need to solve for A, so I'm going to cross multiply to solve for A. I'll put this over 1 and cross multiply. A times tangent of 30 is equal to 1 times 4, which is 4. I need to get A by itself. Remember, this is multiplication, so I'm going to divide by tangent of 30. Those cancel. And I have A equals, remember, I'm not going to write a decimal. I'm going to leave it as 4 divided by tangent of 30 until, because that's not my final answer. That's exactly what I need. I need the apothem, right? So this can plug in right here. So I'm going to do 4 over tangent of 30. Now I'm ready to get my final answer, so I'm going to pull up my calculator again. All right, I'm going to do 0.5 because it's faster. And then we do parentheses. 4 divided by tangent of 30. Close the parentheses, times 48. Hit enter. And I'm going to round this to the nearest tenth. I have 166.3. And then I just need my units, which is feet. So 166.3 feet squared. Okay, so that is it for this set of notes. I want you to realize that we are going to do more of this on this day 2. So if you need to watch the day 2 video, that you can also do that. All right.